Welcome to Easy Elim Learning Simplified. My name is Ruth, and today our today's topic will be water and hydrogen from one work. And our subtopic, we are going to be looking at some of the properties of hydrogen gas. We are going to break this subtopic into two sections. So today we are going to look at some of the physical properties of hydrogen gas, and then we're also going to look at some few chemical properties of hydrogen gas and then look at some questions. So we are not going to fully finish up on the chemical properties. So you need to watch out for the next video when we will be discussing the rest of the chemical properties of hydrogen gas. So first you start with the physical properties. So some of the physical properties of hydrogen is that it's colorless and odorless, and it's usually insoluble in water. That is the reason why it can be collected by overwater method. And then also it's less dense than air. It is lighter than air in simple terms. That is the reason why it is collected by upward delivery. And some of the chemical properties of hydrogen is that it has no effect on the litmus paper. It is neutral. So if you put a wet litmus paper in a gas jar containing the hydrogen gas, it's not going to have any effect on the litmus paper. It also burns with a pop sound when mixed with air. So this is the chemical test for hydrogen. And also, when it comes to pure hydrogen, it never burns with a pop sound. The one that burns with a pop sound is when it has mixed with air. But the pure one, it burns with a blue flame. And when it burns with a blue flame, it produces water. And then also hydrogen does not support combustion, but it also burns in air because you have said it burns in air to produce a blue flame. And then it's a reducing agent, and that is actually what we are going to be discussing today, this property of hydrogen acting as a reducing agent. So we say that the chemical test for hydrogen is when you're explaining yourself is you introduce burning splint close to the gas jar containing hydrogen gas. If it burns with a pop sound, then we say that the gas that is being tested is a hydrogen gas. So let's look at the chemical property and specifically the reducing property of hydrogen. So the reactions of hydrogen, one of them is hydrogen can react with copper 2 oxide. So dry hydrogen is passed in a combustion tube containing copper 2 oxide, and then any excess hydrogen gas is burnt at region Z. So this is the procedure. So we usually pass dry hydrogen through the combustion tube before you start heating. The reason why we pass this hydrogen gas through the combustion tube is to drive out all the air. The reason why we drive out all the air from the apparatus, it is going to reoxidize the metal. So when the reduction process occurs and we are left with the metal, if we had not driven out all the air is going to react with that metal and form an oxide again. So we're not going to get the product that we intended to get. Then second reason is because when you mix hydrogen and air and you see we are burning it at region Z, what will happen is going to explode. So instead of it burning here with a blue flame like we intended it to, because it has already mixed with the air present in the combustion tube, it is in turn going to explode. This is because it has mixed with air. Another reason, we pass the gas continuously and then it's collected at the Z, and then it's burnt. You do not let the gas go into the atmosphere. And then when the gas has already been passed through the apparatus, we also heat copper 2 oxide. You can see the sign of heat. And then after the reaction has finished, we allow the apparatus to cool. And even as we allowing the apparatus to cool, we have to let as we allow the hydrogen to pass through, we allow the apparatus to cool. The reason why we are doing this, we do not want to stop the hydrogen from passing through because it's going to cause the metal to be reoxidized. So that's why we still continue passing hydrogen. The hydrogen will prevent that from happening. And then the excess hydrogen is burnt at region Z because we do not want that hydrogen gas to go into the atmosphere. We have said again that if you mix hydrogen with oxygen and you ignite it, the word ignition might be there. So if you ignite it, it's going to be explosive. That's the reason why we do not allow like the hydrogen to go into the atmosphere. So those are some of the reasons why we did some of the things that we did in this experiment. So what is it that we hope to observe when the reaction is complete? One of the things you'll note is that the black solid, and the black solid in this case is a copper oxide, will turn into a brown solid, and the brown solid is a copper. So the black solid is the copper oxide and the brown solid is the copper. So you notice from copper oxide to copper, there's an oxygen missing. So that is the oxygen that will be taken by the hydrogen. Another observation you'll notice is some colorless liquid are going to be formed at the cooler parts of the combustion tube. And these colorless liquids can actually be tested. So we said previously that this colorless liquid can be tested with anhydrous, copper 2 sulfate, and anhydrous copper 2 sulfate is white in color. So if you add the colorless liquid, it's going to form a blue hydrated copper 2 sulfate. So that is going to be our product. And then the hot black copper 2 oxide is reduced by what? It's reduced by hydrogen to form the brown copper metal. And then when that happens, also there's something happening to the hydrogen gas. The hydrogen gas is being oxidized. Initially, we start with hydrogen gas and then we finally end up with water. If you look at this, you notice that the hydrogen gas has an addition of oxide. And this tells you that it has been oxidized. So the colorless liquid is confirmed to be water because we talked about using anhydrous copper 2 sulfate, which turns from white to blue. And then an alternative is anhydrous cobalt 2 chloride, which is blue in color, which will turn into a pink color. So some of the equations for the reaction, you can be told to write the word equation or the chemical equation. So the word equation, you can see copper 2 oxide and you can see how copper 2 oxide is written. We are going to get into the details of forming compounds later in Form 2 work. So copper 2 oxide reacts with hydrogen gas to form copper and water. And you can see this is a chemical equation and you can see how copper oxide is changing to copper and hydrogen is changing to water. So at the jet, you notice there's also another reaction occurring at the jet. We are burning hydrogen in air. We don't want it to go to the atmosphere. And we say that it's going to burn with a blue flame. So what is the equation? So hydrogen burns with oxygen to form water. So at the blue flame, what blue flame is forming is actually forming water or steam. So in conclusion, our hydrogen is a reducing agent and it reduces copper 2 oxide to copper, while itself it undergoes oxidation to form water. So if we were to write the equation, so we said it is copper oxide reacts with hydrogen gas to form copper metal. plus water. So you see copper oxide is undergoing reduction and the hydrogen gas is undergoing oxidation. So the one that, if you look at hydrogen gas that undergoes oxidation, it is the reducing agent, and the copper 2 oxide is the oxidizing agent. The reason why it is oxidizing agent because it's the one that is doing the giving away of oxygen. So that is what we have learned in regards to hydrogen. Next, let's look at one KCSE question in regards to what we have discussed today. So the setup below was used to investigate the reaction between dry hydrogen gas and copper 2 oxide. So we can see the dry hydrogen is going to be passed through a U-tube containing substance A. We are not told the beginning of the hydrogen if it's dry or not, but we know after it becomes dry, which reacts with copper 2 oxide and the excess hydrogen is burnt at the flame. So name substance A. So we know that substance A is going to dry our hydrogen. That's why we are reacting dry hydrogen. So this is a drying agent, but the drying agent that is placed in our U-tube is referred to as anhydrous calcium chloride. And then state the observation made in the combustion tube. So there are actually two observations you note in the combustion tube. First will be the color of copper 2 oxide. So we will say the black copper 2 oxide turns into brown, while there are also colorless droplets on the cooler parts of the tube. So those are the two observations in case you're told to mention the two observations. So explain the observation stated in A above. So we are stating the color change in copper 2 oxide. So copper 2 oxide is reduced by hydrogen gas to copper metal, which is brown. So that is the explanation. If you were to give the other explanation for the formation of water, we would say, and in turn, the hydrogen gas is oxidized to water. So to give the explanation for the colorless droplets on the cooler parts. So that brings us to the end. In the next session, we are also going to look at some of the properties of hydrogen gas, the last bit of it, and which will be concluding some of the content in this topic. So see you in the next lesson.